from Chumpi. Yes, Chumpi, you are from Assam. It's easy for you. Okay. So now it's 4. Okay. So now we are going to start with this pyramid of energy, right? So I told you that the Lindman's law or the 10% law, right? 10% principle. I think most of you remember that law. Okay.
Yes,
I'm
sir.
searching for one of the student who was about to come. Whose name is Ashish Dabral. Is he here? Okay, I think he's not here. Okay. So 10% principle. This I told you earlier, right? So what is this principle was? This principle was that if sun is providing us with some amount of energy, suppose 1000 kilojoule, so it is based on what intensity is reaching Earth, what intensity of light is reaching Earth, and primary producer gains approx 10% of what is coming from sun. Then they pass 10% of what they have to the next level, then 10% to the next level, then 10% to the next level, then 10% to the next level. Rest 90% is lost as heat. Okay, rest 90% from each trophic level is lost as heat during respiration process. Okay, because at every trophic level, suppose we are human, and we human. Yes, Joseph. Good evening.
Yes, good evening, sir.
Okay, please mute your mic. Okay, as we human, suppose we are on secondary or tertiary level. Okay, so what we do, we can get 1% of what is available at producers if we are secondary level. When at primary level, we will get 10%. This is the reason why it has been said that we must be vegetarian. Okay, though there are several other aspects as well, but being vegetarian makes us the primary producer, right? So at this level, at this trophic level, we would have more amount of energy available to us directly from the producers, right? Rather than eating goat, which has lesser. Okay. I was sorry that I didn't started my camera. Okay. Okay. So you should have told me, right? कोई बता सकता था मुझे कि camera is not okay. Camera is not working. Then what I was telling is that 10% law is followed, right? Are you there?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Then I was telling that why humans are supposed to be vegetarian. Okay. So let us suppose we are the secondary consumers, then only 1% of the energy at the producer level would be available for us. And 90%, or you can say the 99% of what is available at producers would be lost or would be used by the other levels in their respiration and lost to surrounding, right? It would be lost to surrounding, right? Then we can see that by reaching at the top levels in trophic pyramid, in this pyramid, very little amount of energy is available, right? Only 0.01% is available at the 5th trophic level. So seldom we witness more than 4 or 5 trophic levels. Okay, बहुत कम देखने को मिलता है that we have 5 or more trophic levels in an ecological pyramid or energy pyramid, right? Food chain में भी 4 or 5 trophic levels ही देखने को मिलता है. I told you earlier also, right? Then because very low amount of energy reaches there. Now the unidirectional part. So this energy pyramid is always upright, right? I told you earlier also that this energy flow is always unidirectional. That is, it flows from producers to consumers. There is no other way. Yes, Animesh, you have a doubt that even though animals are later in food chain, but meat generally has a high fat content. That is because of bioaccumulation. I told you earlier that yes, they have high fat content because their body developed. There are changes that body accept. Okay, adaptation is there. There is adaptation in the body of organisms. When they are at higher level, they accumulate more energy in their body and use less. Yes, Animesh. Okay, I'll come to it. Okay, I'll come to it later. First, complete this part. Okay. Animesh, you can write in message. Okay, I'll answer it. I'll come to that part later. Let me first complete this unidirectional part. So I told you earlier also that there is unidirectional flow of energy, right? Unidirectional flow of energy. It flows always from the producer towards top consumers, right? And the amount of energy goes on decreasing. And yes, we witnessed that there were inverted and upward, okay, upright and inverted pyramids in both the number pyramid and the biomass pyramid. But in energy pyramid, there is no downward movement of energy, right? It is only unidirectional. So we have only upright energy pyramid. No inverted pyramid is energy pyramid is possible. Okay. Yes, Animesh. Now you can ask. But then eating animals will give a higher energy with respect to intake amount. So why are eating primary consumers better? This question is to be answered in different aspects. I told you that being vegetarianism has different aspects as well. Okay, so yes, energy available for by being the primary consumers is large amount. Okay, this being primary consumers, the humans would have larger amount of energy available for them. Being a secondary consumer, they would have to spend more energy. Okay, they would have to spend more energy to gain energy from this secondary primary consumers. Okay, how to explain this? We can say that in fields, I'm not getting how to explain this, because primary consumers are eating this. They are generating methane when they eat this. These producers, they generate methane, right? But when they are eaten by secondary consumers, more amount of energy losses can be seen, right? When they have when they took to sorry, okay, I'll discuss this part later because I'm not able to make it very clear, so I'll discuss this part later.
Sir, a point from my side, sir.
Yes, Arpit.
Sir, like sir, Ramesh asked, sir. Sir, like if we consume the primary producers, like the primary consumers which feed on the primary producers, so sir, in metabolism or in digesting these primary producers, the energy spent is very least as compared to the energy spent by secondary consumers in consuming primary consumers. So their main energy intent is very much reduced, and most of their energy is lost in either consuming or utilizing those, sir. So the energy drop
Yes, Arpit.
by them is keeps on reducing because the more amount of energy is required or lost in consuming or extracting the nutrients from those once we have eaten them, sir. So
Yes,
so
I put that point also. That we have to spend more energy in consuming the primary producers rather than eating producers directly. I put that point as well.
Sir, but like animal fats are basically processed, right? Because they have already processed the nutrients from producers.
Yes, but they are saturated fats. Okay, they are saturated fats. We have to spend more energy in consuming the saturated fats, right, Animesh?
Oh, yes, sir.
While the producers have unsaturated fats, and we have to spend less energy in consuming the unsaturated fats. The unsaturated, yes, Animesh.
Got it, sir.
So the point was that net amount of energy is more when we are eating producers rather than primary consumers. Then this pyramid of energy is clear apart from that topic. Okay, this pyramid of energy is clear to all.
Yes, sir.
Pooja, Preetam, are you there?
Yes, sir.
I only want to know that this pyramid of energy is clear apart from that vegetarianism topic. Just let us be clear, okay? Yes, Kirti. Okay, so let us move to the next topic, okay? So today we are going to this nutrient cycling part, right? So I told you that energy flow is linear, okay? Energy flow is linear. While the nutrients, they recycle, they get recycled, okay? They get recycled. For example, we can take this nitrogen part. We have nitrogen almost 78% in here. Okay, this nitrogen is fixated by nitrogen fixing bacteria to the soil, and this nitrogen is then utilized by plants and organisms. Okay, then these plants, they utilize into their various metabolic activities, and this nitrogen enters the food chain, right? This enters the food chain. And then we have animal at the top level, consumers. And when these plants and animal die, the decayed matter generated for then again adds the this nitrogen to soil. Okay, which is then later denitrified by denitrifying bacteria back into the air as NO2, nitrogen oxide. Okay, and in between, yes, respiration part also from the plant and animals, this part also generates an amount of NO2 to be released in atmosphere. So this is a kind of cycling. Okay, I'll come to that cycle of nitrogen as well. Okay, so it is only to tell you that there is a cycling of nutrient. Okay, if nitrogen is one such nutrient, then we see a cyclic movement of nitrogen. There are other nutrients as well, like carbon dioxide. Okay, then phosphorus is there. Okay, and also we would see how these cycles, these natural cycles, are impacted by activities of man. Okay, how they are altered by man. How they are altered by men. Okay, you'll see the impact of men on these cycles. Like in this nitrogen cycle, use of fertilizer on one hand and acid rain has been an impact or result. Okay, so acid rain is a one of the causes, nitrogen in the air. Okay, so the first thing we are going to do is you can write the definition of these biogeochemical cycles or nutrient cycle. Okay, so the definition for this biogeochemical cycle, what is this biogeochemical means? Bio means living, right? Bio means living. Then this geo part means rock or related to earth. Then this chemical, we are well aware that they are chemical components. Okay, so these chemical components, when they move between this rock and living, indirectly you can come back to that the ecosystem part, biotic component, abiotic component. So the cycling of nutrients between biotic and abiotic, then back to biotic, then back to abiotic, this cycling of nutrient between abiotic and biotic component of ecosystem, this is the biological nutrient cycling. Okay, or biogeochemical nutrient cycling. Okay, so the definition we are going to write is the flow of nutrients between different spheres, between the flow of nutrients between different spheres, the flow of nutrients between different spheres like atmosphere, lithosphere, hydrosphere and biosphere. In a cyclic manner, the flow of nutrients between different spheres like atmosphere, lithosphere, hydrosphere and biosphere. In a cyclic manner, between living and non-living components, is called biogeochemical cycle. Between living and non-living components is called biogeochemical cycle. Should I repeat? Done or not?
Yes, sir, written.
If anyone wants me to repeat, I would. Okay. Okay. And I assume that everyone has done it. Okay. Preetham, have you done that? Preetham, please reply. Uttam, done. Okay. So this figure is explaining you that how the carbon dioxide or the nitrogen, they get recycled again and again. Okay, that is their amount is very much same in the environment. Okay, let me give you an example from the current. Okay, so what happened? There was 280 to 300 ppm. What is ppm? Parts per million. Okay, this is from emission report. Okay, emissions report, so of IPCC. So that is Intergovernmental Panel on Climate Change. So as per this IPCC report, they say that there was 280 to 300 parts per million presence of carbon dioxide in CO atmosphere. Okay, in atmosphere. And this was the range in past million years, right? In past 1 million years, this was the range of CO2 concentration in atmosphere. But since 1970s, after the pace of industrial revolution gained, okay, especially in the Western and Oriental world. Western means those developed countries, and this Oriental is Asia and South Asia, okay, and South Africa, right? So this was the figure for last million years. But due to increase in pace after 1970s, the tons of CO2 emission has increased rapidly. And recently in 2016-17, it was found that the concentration of CO2 is 407 parts per million. It was a recent finding. Okay. And what CO2 does? CO2 helps in the role of CO2 is peculiar to glass in glass house effect, right? What is this glass house effect? I had asked this question earlier also. What is this glass house effect?
Sir, may I, sir?
Yes, beautiful.
So, like, sir, we make a glass house, sir, wherein we plant the trees. So once the rays which enter into the glass house, they are retained inside the glass house. The warmth, the heat is retained inside the glass house itself, doesn't move out. Similarly, the gases, sir, they act as a glass. They provide a glass house effect because the sun's radiation which are entering inside the earth, sir. So the heat retained by these radiations, it is not able to move out of the atmosphere of the earth.
Okay.
So overall, it results in the increase in temperature of the earth's atmosphere. This is what is glass house effect.
That's good. Anyone else? Animesh, you were trying to answer, I think.
Like, I guess Arpit sir, he explained very nicely, but if you want me to go again, then I will go in the way that the light rays that are coming from sun, they are generally in the visible spectrum, so they are able to pass through glass because of the properties of glass. But when they enter and hit the ground, then some energy is absorbed by the ground, and then they convert to infrared rays, which are not
able to pass the glass. Then this
the heat is retained inside the.
So these trapped radiations get trapped by the glass, and they increase the amount of temperature in this house, right? So this helps in raising temperature and doing agriculture in polar areas or in temperate region. In these temperate and polar region where temperature is very low, sub-zero ranges are very normal. Okay, so in these areas we use glass house. So similar is the work of this CO2 or the greenhouse gases. What they do, they trap the long range radiation from sun. Okay, the long range radiation coming from the sun, these are trapped by this CO2, and this trapping of these radiation increases the temperature of Earth. The same thing we are witnessing now. Okay, which is called global warming. Okay, global warming. So this, what I want to tell you is this rise of CO2, जो कि 300 से 400 हो गया, that is rise from 300 to 400 ppm parts per million, is leading to increase in temperature of Earth. Okay, is causing global warming. So where this CO2 came from? Okay, it was earlier the carbon is almost equal. Okay, it was similar, the same carbon present, the amount was same a million years ago and the amount is same now. Okay, but what happened? The carbon which was trapped in trees, okay, which was trapped in oceanic bodies, water bodies, which was trapped in soil, the large amount of these carbon is released into atmosphere. How? By the process called deforestation. Okay, by processes called mining. We have mined the soil, we have extracted the mineral, and the amount of CO2 which was present in soil has been emitted. Okay, suppose coal was there, so coal was also a part of lithosphere. We extracted the coal, we burned the coal, the combustion led to release of CO2. Okay, which further added the amount of CO2. So this is what I'm trying to tell, that there is cycling of this carbon. This though there is increase in CO2 in atmosphere, but it has been due to decrease in other spheres of Earth. Okay, because of decrease in other areas. Due to decrease in other spheres. Right. So now we are coming to this topic. There are two type of the classification of this nutrient cycling can be in two ways: the gaseous cycle and the sedimentary cycle. Right. Navya fossil fuel, yes, Navya fossil fuel is right. Then gaseous or sedimentary cycle. So biogeochemical classification into gaseous or sedimentary cycle is based on the aspect of length or duration of cycle, right? So cycle which are perfect cycle or short duration cycle, right? That is between atmosphere, organism back to atmosphere within short duration. These are gaseous cycle. Most of these are gases like nitrogen, carbon dioxide, then oxygen itself, then water vapor, right? Water vapor, H2O, right? So these are the gases which speedily rotate or speedily get cycled, okay, in the environment or ecosystem. Okay, then there are sedimentary cycles and they are called imperfect cycles. Okay, these are long duration cycles, and what happens in them? So here a little bit of geography comes into role. So what happens in Earth? In Earth we have plates like this. Okay, these plates they collide with each other. Okay, these plates they collide with each other. Yes, Bhuwana. Okay, you can ask. Okay, you can ask for doubt in between also. So these plates they collide with each other, right? And this collision results in formation of various landforms. One such example is formation of mountains. Okay, mountains are formed like the Himalayan range due to collision of Indian plate with Eurasian plate. Okay, so these formation of mountain takes billions, can be millions or billions of years. Okay, very long duration. Okay, so when these mountains are formed, they get eroded due to climatic action. Okay, these mountains get eroded due to climatic actions, right? So let us suppose wind or water, okay, like rivers, fast moving water also erodes a part of these mountains, and this eroded material gets transported by various agents like wind, water, glacier. Okay, these agents transport these eroded material. Let us suppose they are transported in a river. So a river erodes here, transport this material, deposits them at the sea, and then this move down. Okay, by a process called sedimentation, they move down as sediments and form a layer one above the other, and this layer get compacted. This layer get compacted and forms a rock, right? Rock, and becomes a part of one plate. Okay, then this plate will again collide with another plate and result in formation of mountain further uprise. So this forms a cycle, right? Are you getting the cycle? Is the cycle clear?
Yes, sir.
Everyone, please. Pooja, Pritam, Sharda,
Yes, sir.
Aditi. Lakshmi, is a cycle clear? Soumya. Someone is absent today, right? Soumya. Okay. So what I am telling you that there is rise of mountain, then erosion, transportation, deposition, sedimentation, then further again rise of mountain. So this is a kind of cycle where materials move. But this cycle is a very long duration cycle. It can take millions of years, right? It can take millions of years. And thus these cycles, as they become part of sedimentary, okay, the sedimentary layer, so these are called sedimentary cycle or imperfect or long duration cycle. Why imperfect? Because these kind of cycling is not very much known. Okay, we are very less sure of how it gets completed because it is a very long duration cycle and we do not have as much data as required. Okay, while we have much data on these gaseous cycles. Okay.
Sir, please repeat this one, sir. Gaseous
Which one?
The gases, this one. They can classify as gases, sir. There was some problem with my internet connection.
Gaseous cycle. Do you want me to repeat the classification, Naurim?
Yeah, yes, sir. I just nutrient cycling. I wrote the definition, sir. After that, there was some problem with my internet connection, so I.
Okay. I will repeat. Don't worry. Okay. So the gaseous cycle, Naurim, the gaseous cycle is a short duration cycle, and they gets completed within the spheres of atmosphere and lithosphere, or between the organic and inorganic components, right? For example, I took the example of carbon dioxide. So carbon dioxide from the atmosphere is taken by plants by the process of photosynthesis, which enters the food chain, moves on, and then released by organism by respiration, or after the dead and decay material, they enter as organic material into soil. Okay, which again is consumed by various plants and organisms, and this again is released to environment. Okay, now so this was the short duration gaseous cycle. Okay, now right? Then there is sedimentary cycle. So is it done or should I repeat this also?
No, okay, sir.
Okay, Soumya, why is sedimentary cycle a part of nutrient cycle? Are we considering the cycling of nutrients in the rock? Yes, Soumya, we are considering the nutrients moving in the rocks, right? We are considering. But here, from the ecological perspective only. We are not entering the chemical science perspective that how iron is moving or how other, we are only going to discuss only two of these phosphorus and sulfur. Why? Because they are very much important nutrient for the soil. And I told you that soil is something which can sustain life. Soil is something which can sustain life. And these important materials, these are macronutrients, right? Soil have macro as well as micronutrients, and we are focusing here on macronutrients of soil only. Okay. Then I think I should move to the next topic, which is sub part of this sedimentary cycle, this gaseous cycle, right? This gaseous cycle. And the first in gaseous cycle, the first topic is hydrological cycle. Okay, you people have written that types of cycle. Please write the types of biogeochemical cycle: gaseous or short duration cycle, and sedimentary or long duration cycle. Please write this part. There's nothing such definition. You can write this much only, that biogeochemical cycles, gaseous cycle, sedimentary cycle, perfect or short duration, or imperfect and long duration. This much. You can make a chart like this. Okay. Then this gaseous cycle. Okay. So this gaseous cycle, this hydrological cycle is very much important. This hydrological cycle is very much important, as it determines the water vapor present in, okay, the first layer of Earth's atmosphere is called troposphere. Okay, let me give you an idea. This is troposphere, then stratosphere, then we have mesosphere, ionosphere, and exosphere. So that will come when we will study that atmosphere part in detail. Okay. For now, you can only know this much, that this is troposphere, this is stratosphere. Okay. So the first layer of atmosphere, which is on this, this is Earth. Okay. The first layer of atmosphere connected, touching Earth, or you can say joined with Earth, is troposphere. And 90% or more than 90%, you can say more than 90% of the climatic phenomena, whether it is rain or lightning or movement of clouds or anything else, right? More than 90% of climate phenomena occur in this troposphere. Okay, in this troposphere. And the reason for these 90% to occur here is the presence of water vapor. Right, the presence of vapor, water vapor, to be specific, water vapor. And this movement of water vapor on the cycle on Earth is the water cycle or hydrological cycle. The water cycle or hydrological cycle. You can say that, you can write the definition as well, that hydrological cycle is the circulation of water in Earth's atmosphere driven by heat energy of sun. Okay, how this hydrological cycle work? The water gets evaporated. Okay, let me first remove this. Okay, so how it works? The water gets evaporated from the ocean. Okay, then the formation of cloud begins. Then the transportation from takes place, and as the cloud, the water vapor becomes heavy. The droplets become heavy. This water comes down as precipitation. Okay. Then there is a runoff into rivers and oceans and lakes, right? When in colder areas or in polar regions, it comes as snowfall. Okay, snowfall. And this water can flow to rivers, streams, oceans, seas, ponds, lakes, or the groundwater, right? Which again comes to ocean in most of cases, and then again evaporated. And then the cycle continues. This is simply the water cycle. Okay. And it consists of the cyclical processes of evaporation, transpiration. What is transpiration, anyone?
Loss of water vapors from the leaves by heat.
Yes, you are right. Well, okay, so was it a bit faster? मतलब आजकल थोड़ा जल्दी हो गया क्या? People seem quite okay. Dishank, so थोड़ा slow हो जाते हैं, cool down हो जाते हैं. So clear till now, whatever I explained till now, clear to all.
Yes, sir.
Yes, sir.
Okay. Because these topics are simple, right? These topics are simple. I remember I first read this water cycle in second class. So a basic awareness is there. Okay. I think everyone knows a little about it. Okay. So the circulation of water. So what is transpiration? As Palak clearly mentioned, transpiration is the evaporation of water from trees. Okay. From the leaves of trees, the water gets evaporated from the stomatal opening, and this evaporation. Yes, Preetham, do you want to ask something? Preetham, सब clear है ना? Preetham, please answer. अरे डरो मत भाई. Openly put your views, okay? Then there is evaporation, right? From the leaves, from the stomatal opening of leaves, and this evaporation of water from the trees is called transpiration. So there is evaporation from the water bodies, there is evaporation from the trees. Okay, this is called transpiration. And I told you that the leaves in desert areas are waxy in nature, and their stomatal opening is very small, and this waxy layer on the leaf, it prevents the rate of transpiration. so that the water does not get lost in those desert conditions, right? In the dry areas. So what we were here on, transpiration. Then condensation. After this evaporation, the vapor gets condensed into droplets. Okay, it aids in formation of these clouds, right? Then there is movement, transportation. Then there is after this cloud formation, then there is precipitation or rain, simply rain, right? And then there is runoff. Okay. So this is kind of figure. Okay, this is evaporation and transpiration. Then we have a part of runoff. Then we have this precipitation. Actually, this is a kind of figure I was using. This figure is just to explain that the water, how the water is moving. Okay, this is evaporation. This is runoff, the water which is moving out of the cycle. Like, then this is precipitation. Then you can say that this is water loss due to human activities. Okay, and this part is now much bigger. Okay, this part is much bigger than it was earlier. Okay. So this losses of water due to human activities is much larger now. This is the precipitation that goes to streams and seas. Okay. This is natural runoff to groundwater, and this is losses due to human action. You do not need to draw this figure. It is just to explain. Okay. It is a kind of balance. Okay. What moves up, what comes down. Just a kind of balance in water cycle. So now you people will tell me what are the impacts of human actions on this water cycle. Come with your answers. Speak yourself. Please. I'm waiting for your answers.
Sir, deforestation leads to lower transpiration.
Yes.
Use of chemicals from industries and all causes acid rain, and these acids are going directly to the water bodies.
Okay, acid
Also-
rain, though it is not very much considerable here. Okay. Yes,
Also, due to
Animesh?
global warming, the big ice bodies like glaciers and Antarctica,
So you want to say melting of glaciers.
yeah,
Melting of glaciers, right?
they are also disrupting the cycles.
Okay, they are also disrupting the cycles. Okay. Anyone else? Industrial chemical search. Okay. Anyone else? Arya?
Due to increase in temperature or greenhouse effect, all this cycle get disrupted because due to increase in temperature, the
Yes.
water levels also get impacted.
Most of you might be aware. Actually, I told you the climatic importance. Okay, climatic importance of water vapor, right? So we very well know that this movement of water is very important for us, and they are this most of the data is from website of NASA, and they are very well tracing the movement of clouds, precipitation, climatic changes that are taking place. Because rain is very important part on Earth, right? So you can go on website of NASA and you can read about this hydrological cycle if you want to. Okay. Yes, over exploitation of groundwater, Navya. Yes. Okay. So why I'm telling you, because this water vapor holds very significant. It is very important, right? It holds a large significance in our life. Johannesburg. Okay. So now, first of all, you will tell me where I mentioned this city, where it is situated, in which country. Then I'll tell you what I'm
Africa,
doing.
sir.
Yes, Naureen.
Africa.
Africa.
Africa is not a country; it's a continent.
Country,
South Africa.
South Africa.
Yes, Ashish. I think now you are there. Ashish Dabral, right?
Yeah, this is my first class actually.
You came very late, right?
Yeah, sir, this is my first class actually. I just got the link a little bit late.
Okay, okay. Don't worry, don't worry. So I think water cycle is a simple topic, right, Ashish? And it's not that tough that you cannot understand it. Okay. So we are
Yeah.
only discussing the. I've just recently told that how the water circulates in environment, and the next we are discussing is impact of humans. Okay, how humans have disrupted this water cycle. And yes, you can read from NASA's website this hydrological cycle, because there is a separate domain, okay, on this climate research. Then coming to this Johannesburg, okay, where I told you about this Johannesburg. Okay, for the newcomers, this is not the question, okay. Those for those who attended my introductory lecture, where is this Johannesburg and what happened at Johannesburg? Anyone?
Kyoto Protocol.
No, Kyoto Protocol was not at Johannesburg, right? It was in Kyoto, the city of Japan.
That is second Earth Summit in 2002. What you
Yes,
mentioned.
second Earth Summit. Second Earth Summit. The first was held at. The first Earth Summit was held at Rio de Janeiro, Brazil, right?
1992 in
It
Rio
was
de
in year
Janeiro,
92.
Brazil.
Yes, Rio de Janeiro, Brazil. The second was held in 2002. Okay, in 2002. This is for the newcomers like Animesh or this Ashish, right? Soumya. I think these people, Joseph, they didn't attend my that introductory lecture. So in 2002, the second Earth Summit was held in Johannesburg. Okay. Second Earth Summit in Johannesburg. Now the question for the newcomers, okay, like Soumya, Ashish, Animesh, and few other words also there. Okay, Uttam, I think for the newcomers, right, who did not attend that first lecture of mine. So, what are the capitals of South Africa? Okay, what are the capitals of South Africa? Yeah, I think you don't have to answer that. You were there, I think.
Cape Town?
Yes, Ashish, Cape Town is one such one of the answer, right? Let me give you a hint that there are 3 capitals of South Africa, and one answer is Cape Town, which is administrative capital. Okay, Animesh, you don't know, then Soumya, please. I don't remember others. Okay, then Ashish. Okay, Cape Town. So there are 3 capitals. There's Cape Town, which is administrative. Then there is Pretoria, and then we have Bloemfontein. Okay, so these kind of questions are of bygone days now. But okay, if you can have the knowledge, it's good. Okay. So now coming back to this part here, then Johannesburg. Why I was discussing this Johannesburg. So recently, what happened in Cape Town and Johannesburg? I think in Cape Town it was that the city was on the verge of water crisis. Water crisis in Cape Town. ये news सुनी थी किसी ने? Does anyone of you heard that news? The city was having only 90 days of water left. I think in January 2019 it was. In January 2019. Only 90 days of water left. And the water was distributed with that ration system. Okay. We know that PDS system in India is there. Okay. Ration system. So the municipal corporation started distributing water from that ration system. And a similar situation was witnessed at Latur. Okay, where is this Latur situated?
In Maharashtra, sir.
Yes, Aditi Darkunde, it is in Maharashtra. Then similar situation was witnessed in Chennai also. Okay, though not the 90 days limit was not there, but this water crisis was very severe. And as per UN, almost 1/3 of population is going to witness severe water crisis in coming years. Okay, by 2035, I think. Okay, so why I'm telling you, because the impact of humans in water cycle led to these kind of developments, right? What humans have done, they have formed dams generating hydroelectricity, right? This has hindered the free movement of water in rivers. Okay, what has been done? The embankments. Okay, embankments are side, you can say side boundaries are created on the rivers. So the flood plains do not get enough amount of water. Okay, then there is large scale agriculture and animal husbandry. Large scale agriculture and animal husbandry. And as per the government of India report, as per the government of India report, 80% of fresh water in India is consumed by this agriculture sector only. They have divided this into 3 sectors: the industrial sector, the residential sector, and this agricultural sector. And 80% of India's groundwater is utilized by groundwater. Okay, is utilized by this agriculture sector only. And we know that most of the rivers, they are diverted. Their water is diverted for the use in agriculture. Okay, so what happens? The amount of water which was earlier available for forest or otherwise is now absent, which reduces the scale of transpiration. This transpiration get reduced on a large scale, right? Then irrigation, canals have been developed. Then one such major reason is concretization. What is this concretization? Anyone? What is this concretization?
Sir,
You can give answer in messages, right? What is this concretization? It is not about roads only, Palak. Yes, building concrete, you can say structures on land. Modern city built at forest areas. Animesh, you are talking about land transformation, land use transformation. Okay, modern city built on forest areas is about land use transformation. I'm talking about concretization. It is the making of concrete structures on land. Okay, and this, yes, Soumya, you are right. This reduces the seepage of water inside the earth. Okay, so the soil layers inside the earth have very little amount of water, and the sustenance, okay, the life sustaining capacity of soil reduces, which further decreases the growth of plant. Okay, yes, Ashish, anything you want to ask? Okay, so this all is about the human activities. Okay, concretization has reduced seepage of water into the ground. Okay, which has increased the amount of runoff. And the larger runoff means the rainwater gets wasted. It is not absorbed and it directly goes into the sea or oceans. Okay. So the earlier with the water which was evaporated from the land part is absent now. Then use in motor vehicles, animal husbandry, right? So we are discussing about the changes the humans have brought in the water cycle. So the evaporation is impacted greatly. Okay. Then the amount of temperature rise has caused this condensation, the slowdown of this condensation. Okay. and also the temperature variations, because the movement of wind, okay, the movement of wind is due to heat. The sun's solar energy is the primary source, as I told here also, that the primary source is heat of sun. So when there is increase in temperature, the movement of clouds also gets varied, and this causes erratic rainfall. और इससे क्या होता है? The farmers do not receive the required amount of rainfall, and this leads to failure of agriculture and other economic disasters or ecological disasters as well. Okay, so I think we are done with this impact. You can write it if you want, that the hydrological cycle definition written, Arya, which doesn't allow water to penetrate water in the ground. Yes. So this I think definition you people have written. Okay. Okay or not? Please speak.
Sir.
Okay, now then. Okay, Arya, Harsh, Animesh. Then this cyclical processes. Okay, you can write it as a you can write this like this line and this. The cyclical processes involved. Then evaporation, then condensation, transpiration. Okay, you can write this process of evaporation, transpiration, condensation, cloud formation, precipitation, runoff, and groundwater flow. Okay, then you can come to impact of humans, and here also you can write these points: generating hydroelectricity, irrigation, deforestation and greenhouse effect, concretization of land, then agriculture and animal husbandry. I'm repeating the impacts. It is about generating hydroelectricity by dams, irrigation, deforestation, and the greenhouse effect, concretization on land, and finally agriculture and animal husbandry. Should I repeat or done? How building of dam affects hydrological cycle. Navya, I told you that this is also kind of concretization. We are hindering the natural flow of river, and hindering this natural flow of river, what it leads to? We are
not stopping it completely, right? We are allowing it to go also, because we can't stop all the water that is coming.
We are not stopping all the water. We are hindering the flow and diverting the flow, right? We are hindering the flow and diverting the flow in terms of by making canals.
Yes, sir, but still the water, water is available for irrigation and forestry. Everything water is available. So how is it affecting hydrological cycle?
It is affecting hydrological cycle in a manner that the climatic condition here can be different. So the rate of amount of water vapor that gets evaporated can be different of what it was earlier, right? It might be that the water in this canal is used for industrial purposes, so it is not available for evaporation as it was earlier. Okay, it might be that this river is more polluted, this stream is more polluted, and the rate of evaporation is not as good as it was earlier. Okay, it might be that this this stream of canal passes through very arid region. Okay, so the rate of evaporation is very fast than it was earlier. So this stream gets dried. Okay, so there can be these changes in others. Okay, who was asking this? Navya, I think. Okay.
Yes.
Clear, Navya?
Yes.
Yes, Soumya.
So eventually the water flowing through the river was going to add on to the sea or ocean, which was the loss of fresh water. So building dams to conserve those fresh water is in a way good, right? Like environmentally good, because we
Every
are
coin,
conserving the fresh.
Soumya, every coin has two faces, right? Every coin has two faces. Because building dam is good for humans for now. In the short run, it is good because they can generate electricity. Okay, they can canal irrigation is possible. Okay, then there are other features as well, like water tourism is there, right? Like in that, I think Guru Nanak Dev, sorry, Guru Govind Singh Canal system. Okay, but building such large structures like them, what they do that the most of the sediments get deposited. Okay, the sediments or the eroded material brought by river, they get deposited on this side only. They are not available on this side. And these sediments are nutrients. These sediments are rock nutrients which are going to be distributed. They are not available to fields, right? Am I good? Then the ecological flow. Then there is ecological flow of water. There must be at least some amount of flow which is enough for the survival of life in water, like fishes. Okay. So suppose we have 3 dams on Chambal, 3 big dams on Chambal, and these dams are leading to decline this ecological flow. And then we have very important species of ghadial in Chambal, situated in after these dams. Okay, near the Chambal, near the Dholpur, I think. So there is Dholpur sanctuary, I think, as well for these ghadial. So when there is no ecological flow, these ghadial would die. Okay, they would die out. So yes, building dams impacts ecology. When there is less amount of flow, the trees, okay, the flood banks, okay, these flood plains, you know what are flood plains? Flood plains are the areas of land adjoining the river. Okay, it is around 2 to 3 kilometer range of that stream. The stream flowing here, and we have the areas around this, the adjoining land areas around this river they are floodplains. So what they do, they absorb water. They absorb water, and evaporation also takes place from the land also, because when land have more than enough water to be utilized by them or by plant. Okay, if land has the water which is beyond its utilization capacity, then yes, with the increasing amount of radiation from sun, this water is going to evaporate. So when this flood water is not going to land, what would happen? This evaporation would not be there. Transpiration of trees would be lesser in this region. ज़्यादा हो गया क्या?
Yes, sir. Yes, sir. I'm here.
I think that's enough.
Yes.
मतलब,
Yeah,
are
yes,
you
I
people
got your
clear?
point.
Are you people clear with my idea, or is should I try and again?
Sir, clear,
Water
sir.
stored in dams get nutrient enriched due to high bacterial respiration, impact the water quality as well as alters the timing of flows. Yes, Palak, you are favoring me or you are questioning me? I'm not able to
No,
get
no,
it.
sir. Actually,
Yeah.
I give the answer. When we store water in the dams, because
Yes,
we
so
build dams,
the
we store some amount of water.
nutrients are on this side, na? And
Yes, sir.
if the floodgates are on this level, then it is difficult to allow these nutrients to flow out. This
Yes, sir.
desedimentation is required. Okay, we need desedimentation. We know you might know that the flooding was good. Okay, you might have heard that flooding by rivers is good for fields. Why is it so? Because when the water from the river flows out, okay, and reaches the field, it provides nutrients. Every year when the flood comes, the water coming out from the river to fields, it enriches the field in nutrients because of sediments it has. Yes, flooding enriches the soil area, yes. So this is the point here. The sediments that rivers bring with them enriches the area. Okay. So I think we are done with this hydrological cycle. Took a lot of our time. Anything else in this hydrological cycle? And then we have this carbon cycle, and as the time is now 5, so I think we should start tomorrow. Okay. So with this, I would like to end my lecture. Any questions for today? Anything you didn't got, or any other question as well?
Sir,
Yes, Aditi.
sir, can increasing population be an impact because
Yes.
it increases the usage of water?
Yes, definitely it's an impact. Definitely, because it increases the amount of water utilized. Similar was the condition of Cape Town. Okay, similar was the condition of Cape Town. It is a tourist place. It is a tourist place, and large amount of tourists were coming to Cape Town, and the population was significant in January. Okay, because in January it is summer in the southern hemisphere. Okay, and Cape Town is situated in south. Okay, Cape Town here it is. Suppose this is Africa. Okay, so you can think, okay, this is Africa, and we have Cape Town here. So it is located in southern hemisphere, and in January it is summer here. So what happened? Large number of tourists were reaching the city, and the amount of water was decreasing in summer. This led to such water crisis. And similar is the condition of Chennai as also. We have such a large population in this metropolitan area, and the sources of water are decreasing or degrading day by day. You might have heard that there was large number of around 40,000 ponds or lakes were there around the city of Chennai. But as per recent data, only 1,000 are left. So when these number of water bodies are destroyed, what happened? The rate of evaporation disrupted, the water availability disrupted, the water seepage to ground disrupted. So the whole water cycle disrupted, and the availability also gets disrupted. Now clear? So shall I leave now? Okay, then I'll take your leave. Thank you. Have a nice day.
Thank you, sir.